apologize. Thank you, Sinclair, for telling us that the recording has stopped. So, guys, please do not stop the recording and do not mute me. So, can you please let's agree on that one? Thank you so much. And I think next time, you see the problem of making you guys all attend this is it makes it difficult for me. I'll have to go from time to time and approve. I see some people are still on the. Just hold on. Let me try to approve. Some people are still in the. They're requesting approval. Okay. Great. So let's go back in introducing the row operation. So I will introduce the row operation just now. We're going to use them before even introducing them. So the whole objective of row operation is that we need to change the first element that in blue to 1. Luckily, our case is already 1. The second one in blue to also 1. And the third one in blue to 1. That was the first objective. The second objective will be if we can change the second one to 1 and the third one to the ones in, green, I'm sure it's in green, to 1, then we'll have to change them to 0, 0. So if we can make them 0, 0, then that will be awesome. So we can make them 0, 0. That means that we have to create zeros in the last column, and then that will help us to see that which type of matrices we're going to have. And then to start with that technique, then my next task is that I have other to make the ones in green. And the ones in green is called the diagonal. So we usually call them element in the diagonal. So one option would be to make the ones in green all 1, 1. And second option is to make the one in red, in yellow, all 0. So let me go and change another one to red to make the one in yellow to 0. And then the one in red, change them to also 0. Right? If I can get those ones in red to 0, and the one in yellow also to 0, then what does that mean? It means in some sense, I'm creating something like this. So try to think of it in terms of a triangle. So I'm creating a triangle of this nature. So you can see that I'm creating somehow a triangle. So it's called a lower triangular path. So if I can get zeros in that path, at a later stage, you're going to know that this matrix with such a path that are all 0, where in that triangle, I put everything becomes 0, it's going to be called a triangular matrix. And then at the stage, you're going to know which one is a lower triangular matrix and which one is an upper triangular matrix. So that is going to come with time. It's not for today. But unfortunately, I have to get ahead of myself to let you know that, okay, when we get the zeros down or we get the zeros on the upper part, then we call the matrix a lower triangular matrix. Then 2. Okay, I said, to start this game of getting the zeros in that triangle in red or getting the 1 for those ones in green, I'm going to have to play a game. And the game is I'm going to use some operations. Operations means those normal operations that we use: addition, division, subtraction, and so on and so forth, right? So my first task, I gave the first one as row number 1. So what I mean by row number 1 is, let me take a different color, maybe a blue color. So row number 1 to say that this element here, all those ones that I put a blue on them, they are going to be in row number 1. So those are the element of row number 1. So then the next one, unfortunately these colors are limited. The next one is going to be, obviously from this one, you should be able to understand that, oh, okay, this is automatically is row number 2. Are you with me? So then if this is row number 2, then the next one will be row number 3. So these are the element or the entries of those specific rows. So then that is the one in yellow is row number 3. So those entries, those elements there, let's say we start with row number 1, the one in blue. There is the first entry is 1, the second entry is 1, and the third entry is -1, and then so on and so on and so forth. So you can also know that. So those are going to be called the entries of the matrices. Those entries are actually the one that collecting the entire information for this matrix, where it gives us the information, and then we take that information, we work with it. Now, to work with the information in row number 2, so I keep row number 1 as it is. I don't change it because row number 1 already has 1 as the first entry. So I'm not interested for now in the second and the third entry of row number 1. I just want to keep row number 1 as it is, and I want to also eliminate row number 2 and row number 3. Before I eliminate row number 3, I can start by row number 2. I can start by eliminating row number 3 first. In a sense, what I mean by eliminate is creating other 0, 0s everywhere, or creating zeros in that triangle that is in red, and then everywhere where there is this thing in green, I must make them 1, 1, 1. So if I can get the one in green also, from the entries of row number 2 and 3, if I can get them to also 0, 0, then I will be more than happy. So let me start by first doing just a simple operation on one row. So the first operation I'm going to do is just one single operation has been done on row number 2. I take my original row number 2. I subtract 2 times row number 1, and then I'm going to say that result, I'm going to put it on row number 2. So my new row number 2 is going to be the result of this operation. What does it mean? It means that I take the first entry of row number 2, which is 2. So the 2 that is in yellow, and I'm going to subtract the 1 in green. So 2 minus 1, that's what it means. So otherwise, sorry, 2 minus 2 times 1. So which means in row number 2, I'm going to say row number 2 minus twice the entries of row number 1. So I say, okay, the first entry of row number 2 is 2. So let me write it here. I'm going to write the operation 2 minus 2 times the first entry of row number 1, which is 1. Then the answer to this one, 2 minus 2 is equal to 0. So I'm going to write 0 here in this position. I hope that everyone is okay with this. Now the next one, so it's become obvious now. The second element in the one in green, the 2 in green. So I'm going to say the 2 in green minus 2 times the next element in row number 1, so which is 1. So you see now I'm targeting these guys here. So the first thing I did this one minus 2 times that one, and then now I'm going to do this one minus 2 times this one. So that is also give me a 0, so then that 0 I'm going to write it here. So these are the first 2 entries of row number 2. So I'm getting a new row number 2, and slightly different from the previous one, but it carries the same weight, it carries the same information. The only difference is that I did some elementary operation on it. I took that row number 2 and I subtracted twice times row number 1, so that I can make the information slightly better in a way to arrange it, in a way I can use it. but the weight and the equivalency, in a sense, what I mean by the weight it carries is the same. So it means that if you are using the original system of linear equation and someone else is using the system that coming from the one in number 2 position, the outcome would be the same. So now the other one is going to be that number third operation is -4 minus 2 times the next element is -2. So it's -4 actually plus 4, then that is again another 0. So I got a 0 here. So in the same way, then I can write row number 3 like 3, 3 minus 6. Or I can do this, oh, it's easy, I just managed to get 0, 0 everywhere. Then I say, okay, instead of me writing 3, 3 and 6 or repeating row number 3, and this operation is so elementary, 2 minus 2 minus 4 plus 4, and then 2 minus 2, and then I get 0 everywhere. Then I'm going to say, oh, I'm tempted actually in a sense, say, okay, inside row number 3, I'm going to say row number 3 because the first element of row number 3 is 3. Then I'm going to say minus 3 times row number 1 because I see that the first element of row number 1 is 1. So if I have 3 minus 3 times 1, I'm going to get another 0. Then I'm going to put this result into row number 3. Can you see some kind of what is it called? Some kind of you see some kind of something that looks the same, some similarity in a sense. You see, I say row number 2 minus 2 times row number 1, I'm going to put it in row number 2. Row number 3 minus 3 times row number 1, I'm going to put the information in row number 3. I did not say that I'm going to put the information in row number 1 because row number 1, it has been affected by I multiplied by a -3. The same thing on the first operation that I did. In row number 1, I multiplied the element of row number 1 by -2. So it means that I cannot put this information in row number 1, neither the first one nor the second one. So the only thing I can do is row number 2 and row number 3. So if I switch here, row number 2 to row number 1 here, then I'm going to get the wrong information here. At the end of the day, the information won't be correct because I already multiplied row number 1 by a -2 in the first operation. So which means that I have changed the outcome of this. But because I did not bring it into play, I was only interested on the outcome of row number 2, and that's why it doesn't affect the system. In the same way, we're going to do here. I'm going to get a 0 here, 0 here, 0 here. So 3 minus 3, 3 minus 3, and then minus 6 plus 6. So it gives us 0, 0. Now, at the start, we wanted those ones in green to all be 1, 1, 1. But we said alternatively, if we cannot make them 1, 1, 1, all of them in the diagonal. So what I mean by diagonal is this one. I think let me use a different color. What I mean by a diagonal, this is from now on, this is, so you know what is the diagonal, and the answer of this diagonal is the one in green rectangular box looking like a plane is 1, 2, and -6. That we call it a diagonal. So it means from this diagonal, you can already pick that there is, you can call it a descending diagonal, ascending, and then the opposite. So we're going to use them later on when we calculate the determinant, this notion, if you want to do a manual calculation or if you want to follow the mathematical formula. Now we see that we got a new system, and I said this new system carries the same outcome as the old one. So now the question is that previously when we said in terms of the system, we said that all the three systems are parallel to each other, and then we managed to get infinitely many solutions in 2 different ways. One way was given to you as a homework to draw that they are parallel. Then you draw the conclusion that because they are parallel, you have infinitely many solutions. And the second one is algebraic option. Now look at the third one. The third one, I only use the coefficient matrix. So now look at it here. If I write the new matrix, I'm going to call it, let's say a matrix B. I will give it a different name. This new matrix will be 1, 1, -2, 0, 0, 0, and then 0, 0. Is someone asking a question? Yes, go ahead.
I think that 2 people want to ask you a question.
Thank you so much. Let's start by Luanda Kile. Luanda, please ask your question.
Hi, sir.
Yes.
I wanted to check that why are we not including the answers in this, because doesn't the row operations affect the answers, or is this a new concept? I'm a bit lost.
Yes, we are coming to it. I said here, I gave you let me go a bit back. I gave you 2 options. You see, I said there is one called augmented matrix and there is one called coefficient matrix, and I'm going to use both of them before I can. You see, you wanted to have the right hand side, right? So we'll come to that one. So we're going to reason in both different options. So we'll see which one is the correct one. So you're going to use this basically for the case of infinitely many solution, and the case of no solution will be covered by this option here. So yes, we're going to have 2. You see, we have augmented matrix where it has the right hand side, and then we have the coefficient matrix is this one. So when we use the augmented matrix, we can answer directly. I'm not sure if that's what's your question.
Yes, that is my question.
Yes, your hand is next.
Hi, good afternoon, sir. I have a question that is not related to the work we're currently doing. Should I ask that later?
I'm not sure. Yes, you can keep it for later, or you can ask, but it will be better if related to the work. So I don't know. You can keep it in